Excellent. I just want to welcome everyone to our 11 o'clock session with Dr. Jason Rowntree. Jason's bio is right there in the whova. If folks would like to learn a little bit more about him, he has a pretty decorated career, and we would love to have you know more about his work in general. He's going to give us a little bit of highlight right now. And if you are, just want a quick reminder, if you are a person who's joining us through the Zoom side and you have questions, please direct message those to myself or Jess Williamson, and because that will keep them from popping up for the folks on the Whova side. So at this point, I'm just going to turn it over to Jason, and thank you so much for joining us today, Jason. We really appreciate it.
Oh, great. Thanks so much, Jen, and for the invite. It's good to see y'all, I guess, remotely still. And so hope everybody's doing well. We are preparing for snow over the weekend, this upcoming weekend. So that's not you just keep thinking spring's popping up and it doesn't happen. So March is always, like, for me, the toughest month to live in Michigan. So hey, I'm supposed to talk about soil carbon and some things like that, and I'm going to talk broad base first, if y'all don't mind, just kind of on where we are, I think, with a lot of things in the industry for grazing livestock, and maybe go over some of our different projects that we've published over the years, and then summarize with some new research that we've recently got funded. And so I don't know if y'all saw recently, but there was a $1 billion RFP, request for proposal, that came from the Secretary Tom Vilsack from he's Secretary of Ag, basically wanting to stimulate the aspect of climate smart practices to be adopted for climate smart commodities. And so there's this massive push, I think, industry wise, to build carbon, to build ecosystem services, and to create greater resilience in the landscape, right? And so I applaud the fact that we're finally looking at these things, and I think simultaneously, though, when it comes to these markets, we can all agree it's crazy. It's like I kind of it feels like just jumping into one of those tornadoes that you see blowing across Oklahoma, and so it is interesting, and a lot of that, I think, was really stimulated by the fact that we more recently signed on to the Paris Accords again. By doing that, it basically creates this aspect that we have a 30% reduction in all of our emissions across industries. It really doesn't factor in with the aspect that agriculture isn't as huge of a footprint as other entities, for instance, fossil fuel industry or some others. But bottom line, it's still pushing for us to reduce these emissions across all categories within the country. And so that is, I think, simultaneously led to a push for industries to look at their value chains. And of course, things always run back to what we do at the farm level. And so that's really kind of the environment that we see today. So I think there's really, like, because of the fact that there is this pressure on animal ag to lower emissions, it also has created this opportunity for, I think, those that don't appreciate meat animal production to get a leg up in certain regards. And that, I think, comes down to three areas that we see typically meat and dairy being pushed back upon, and that's with saturated fat intake in our human diets, climate, obviously, as we've talked about, and also animal welfare. I'll talk a little bit about the first two, but not the third. But it seems to me that it's getting more and more intense. And I see a few colleagues on here that are academics. I thought I saw Dr. Soder, Kathy, and maybe Stefan even from out in Utah. And the point is, like, what you're finding in academia today is, I think, for every one person like Kathy or myself as an example that does grazing research, there's 100 people that are doing modeling in the food in human diet and nutrition, that really aren't nutritionists, and they're not animal scientists, but they're modelers, and ultimately come up with very significantly different ways of looking at our diet and how we farm and ranch. And regardless if it's crazy or not, Kathy and I are outnumbered about 100 to 1 today. And so it gets to be much more challenging when you get into this space. I came across an interesting paper the other day on some human diet stuff, and I'm not a fan of the epidemiology work that often is simultaneously coordinated with these big databases like Global Burden for Disease and other things. But there's paper kind of did use some really old school surveys and looking at diets. And what they did is they tried to go back to the early 1800s and follow what we've been eating from a saturated fat perspective. And then likewise, the authors wanted to compare that to non-communicable diseases in humans. And the interesting thing that they found is that going back to the early 1900s, this blue bar represents animal-based fat consumption, saturated fat consumption, and the orange represents vegetable-based, and that would be soy oils or canola or other types of oils like that. And effectively, as you follow this over time, we now see that our diet has considerably greater overall fat consumption, and a majority of that quite easily is coming from plant-based fats and oils. And the point is that we are perhaps on a fairly plant-based diet. It's just the things that we're consuming aren't good for us. And those most likely are probably, as the authors talk about, are associated with processed food. They actually summarize and state that for the last couple hundred years, red meats declined by 44% per capita consumption. Fluid and cream dairy, 48%. Eggs have gone up significantly. Lard down, butter down, while margarine has increased almost 200%. Shortenings increased 91%. Salad and cooking oils have gone up 329%. And Americans have consumed up to 70% fewer saturated fatty acids from animals by the end of the century, as obesity and diabetes epidemics have emerged alongside an increased incidence of non-communicable disease such as cancer and heart disease. And so the point then is that I think a lot of this work that's out there, and there's others, like if Stefan was indeed on this call, I mean, can talk better about this than I can, but it just seems crazy to me. And in fact, a co-author recently put a tweet out, Ty Beal, who's at UC Davis, actually showing a recent study using this global burden of disease database that actually considers any bite of meat carcinogenic or negative to your health. Basically summarizes that if you look at daily minutes of life, you may have seen the hot dog study, right? Like the hot dog, if you eat a hot dog, it takes this many minutes off your life. Well, it was this study. And they basically summarize the fact that we can eat PB&Js and that'll give us 32 minutes of life. Whereas we eat eggs or red meat and that takes 6 or 7 minutes away. Candy, a little positive. Snack bars, ready to eat cereals, nuts and seeds. So the point is all this stuff's crazy, right? And my kids would probably be pumped. But the point is that it is a way different way of thinking about it. And I think we've just gotten a little off. The aspects of greenhouse gas emissions, and this really ties into kind of some of this talk of soil carbon and climate and agriculture mitigation. I want you to be aware, and this is a little bit older, but it still rings true, that when it look at the overall emissions of our country today, and CO2 equivalents, we find that agriculture represents this green, red, and blue bar at the very bottom of the slide. Therefore, maintaining around 9% of our country's emissions. Of the 9% in our country from ag, about 60% of that is associated with animal agriculture, around 5.4. And of that 5.4, another 60% is associated with ruminants. And so effectively, 2 to 3%. And it is, again, the thing though, is that we are being called to reduce these emissions across, right? And so when you look at ag and you look at the fact that, methane is a significant part of those emissions, we see these crazy calls to lower them dramatically. Interestingly enough, I've had the opportunity to work quite a bit in New Zealand, and New Zealand is a great place because they have more ruminants than people. And I'm trying to immigrate, but you have to have like 5 million in net worth to even immigrate there. So I'm kind of working on that a little bit. But what I want to say is that they have more ruminants than people, and they've also signed on the Paris Accord. So they simultaneously, being a small country, are making dramatic pushes to lower ruminant agriculture in New Zealand and plant trees. But the crazy thing is that their entire country's footprint is less than the beef footprint in the US. And so while, it basically states then that New Zealand has, these type of accords have tremendous ripple effects on global economies, based on metrics I'm not sure are really even believable. And we've been doing this work now at our farm and trying to understand what these footprints and other things look like at Lake City Research for about the last 13 years now. And when I got to Lake City in 2009, we were a traditional beef cattle operation, 600 grazable acres. We had some really nice but pretty large Simmental Angus cows. And I've worked in that space with our research team and laboratory and other faculty to where today we run about, I think I've got a slide. I'll talk a little bit about it, but we run a nice red Angus cow herd. These cows weigh about 1,250 pounds. That would be at a body condition score 5 at weaning. And we've gotten rid of our fertilizers almost like 99%, except for lime. And we've just had this really great site to model what the USDA now calls climate smart practices in a working landscape in Michigan. And so we're up here on the 45th parallel, and this is the work that we do. And so we often, are talking about regenerative ag, and regenerative ag is quote unquote a way that we can get towards maybe what these improvements in carbon are looking like. Honestly, to me, regenerative ag is evolving quite nebularly. And I still believe, though, it's about improving resilience in our landscapes, in the health of our people, the health of our food. Regeneration is actually an ecological term, and it goes back to a system's ability to snap back from a shock. And so it really encompasses resilience. And then regenerative ag would be improving that resilience in an agriculture setting. And we do it by using these principles. And I really want to emphasize the principle and not the practice. We use these vernacular, like I said, like climate smart practices, which to me means check the box, you do it or you don't. A principle is more of a guide, it's an ethic. And those principles have been quite well, I think, publicized, from NRCS to understanding ags of the world to others, but it really encompasses these aspects of minimizing disruption, keeping ground covered, living roots throughout the year, promotion or greater biodiversity, grazing and cropping settings, and then adaptive grazing, right? And so those are the real drivers. And the thing I like about it is what you may do in the Northeast may be different from what I do in the Midwest. And we might find that it's easier or more difficult to apply some of these principles to our farm context. And so, but just because we don't do everything doesn't mean we're not potentially regenerative, right? And it isn't binary. It isn't you are or you ain't. It is a gradient of approaches that can add resilience to landscapes. And that to me is a better way of thinking about it versus the typical check the box, do you do something or not? And then we put people in buckets. It creates antagonisms. I don't like it. And so that's kind of the approach that we've taken here. Keith's work, Postian there at CSU, would indicate there's really some great opportunities to use these soil health principles and livestock management to improve the opportunities for sequestration, of which we can see as high as maybe up to close to like 25 to 30% of our global footprint can be offset with how we farm and ranch, how we manage forestry, and how we adopt technology. Often when you see these numbers about where we're headed, technology is never considered an opportunity to lower things, whether it be methane capture as an example, or neat aspects of things that we don't even know about, or it could be more quote unquote rudimentary type technologies like biochar or other things. And so there are a lot of opportunities that are out there. So this is just one of my favorite pictures from our farm. And the work that we've been trying to do is, use grazing as a way of improving land, of extending the grazing season in Michigan. Hopefully we can do this more profitably. I really like grass finishing. We've done a lot of work in grass finishing over the years, not as much right now because of all the climate work we're doing. But this is kind of our go-to, right? This would be a set of diverse cover with brassicas, kale, there's cowpeas, there's annual ryegrass, there's some oats, there's all kinds of stuff in this deal. I can come into Michigan in October, November and get almost, I think we got about close to 200 cow days an acre, or about 6,000 pounds of utilization off this site. The only times I've used fertilizer at this farm would be in the use of cover crops and alfalfa kind of perennial pasture rotation. We've really tried to manage adaptively and work in that context. And so what I want to say is that in 2009, I inherited our farm, and I don't want to ever be critical about the management. It was what it was. It was a very normal managed type situation. And we were averaging about, about 70 stock days or cow days an acre. I use 30 pounds as an increment, right? 30 pounds of utilization per acre. We weren't even grazing 5 months out of the year. Considering we don't turn out till around Memorial Day, which is probably similar to some of y'all, we weren't getting much into October. At that time, we had about 170 to 180 pairs that were grazing, as well as yearling heifers. We came in and we started what I call, I guess, managing adaptively. We started grouping up cattle. We started grazing to recovery. We didn't know what we were doing, to be honest. It took us a little bit, but we got the hang of things. We ran a lot of interior fencing and water, and we just began measuring. We started more aptly measuring carbon around 2012. I don't confess to be a scientist really great in any one field. I'm kind of a jack of all trades and try to integrate a lot of different disciplines. But point I want to make is we slowly made progress. 2012, if you remember, was the driest year I've had in the 13 years I've been here. We added all of our yearlings, all of our yearling steers and heifers to our system. That's why this gray bar, our pairs and yearlings, went up, because we started doing grass finishing research. We actually were grazing over 150 days, and we were getting considerably more stock days per acre, where we went from, what is that, around 70, 75 up to 80, 85. What I also want to say is that we started grazing our hay ground, and that was the reason we were able to carry that many more yearlings. And so we've been kind of bouncing around in this context. As you see, our cow days per acre actually peaked when we were really trying to be silly and push it up to over 100. We were actually, that year we grazed almost 200 days that year, right? And so effectively, we started doing considerably more cow-calf research again on methane and carbon and nitrogen cycling. So we started selling considerably more yearlings back off the farm. We kept more cow-calf pairs in that system. But what I also want to bring to you in 2021, we're now almost grazing 200 days a year. Our stock days per acre is that year was hitting maybe about 80, but we also took 160 tons of hay off the place, which actually is the first time we've really hayed a lot on the farm in 13 years. And the reason we did that is because with COVID and with all the challenges we had, it just made a lot more sense for us to do that. We thought there might have been some safety in terms of economics as well. So that's kind of our approach at the site that we've been on over the last some odd years. Again, we started ecologically monitoring. We started going in and collecting soil samples across the farm here when we did this as well. Life cycle assessment is something you're gonna hear me talk about from here on out. And it's a way that we manage how carbon cycles through an environment, but it also incorporates other greenhouse gases. And effectively, when we look at life cycle assessment on a kilogram, on a beef basis or a lamb basis or whatnot, we use a kilogram of carcass weight per kilogram of carbon dioxide equivalents. Or so it's a kilogram of CO2 equivalents. The reason we use an equivalent is greenhouse gases have different abilities to trap heat in the environment. So CO2 represents one molecule, or like one global warming potential, where methane is 34. It may have dropped to 25. It's normally somewhere in there. Nitrous oxide is 298. And so the point I want to make is that one molecule of nitrous oxide has 298 times the heat trapping ability of methane. And it would probably have what, 8 to 9 times the heat trapping ability of one molecule of, I think, CO2 for the first one, methane for the second. So one molecule of methane is going to be like 34 times more of carbon dioxide, if that makes sense. So considerably greater heat trapping abilities. We go from CO2 to methane to nitrous. Nitrous is worth 300 molecules of CO2. And the reason I bring this up is because how we measure and the metrics that we use really matter when we talk about carbon, when we talk about offsetting our emissions in a grazing system. The other thing that's really important is that a typical life cycle assessment here, as you see, doesn't factor in water. It doesn't talk about water. It doesn't, reflect the fact that water really drives carbon uptake, not vice versa. And we see these horrible situations with fire in California and Australia and other sites. There was one at my home state of Texas this last week. Close to our place here, Lake Erie, eutrophication dead zones. I know in Vermont, the challenges you have there, was it Lake Champlain, if I remember. And these aspects are important, but yet we don't even account for them. Somehow we've reduced the complexity of nature and agriculture and all the things we do to a molecule of CO2. And it kind of pisses me off because it's a lot more complex and it's a lot more challenging than what we try to make it be. And so just as an example for methane, all the greenhouse gases we look at, we put it on a 100-year global warming potential. So we look at the amount of heat trapped over 100 years for each given greenhouse gas molecule. What I also want to say is that methane actually has a considerably shorter half-life. This is a review a former grad student that's now at Colorado State put together, Logan Thompson. We know that methane is a byproduct of fiber fermentation in the rumen. We get that. Methane then is broken down by hydroxys, by OHs in the atmosphere. And when it's broken down into water and carbon dioxide, which goes back for rain events and is uptaken for CO2. Animals graze the grasses that are grown from photosynthesis and from the water, and it is a biogenic cycle. Importantly, methane is broken down and has a half-life of about 9 to 12 years, not 100. So we put methane on the same global warming potentials we do CO2 and nitrous, yet it's in the atmosphere considerably less. And because of that, it should force us to account for the global warming potential differently, but we don't. And a new paper that just came out last year, done by the Nature Conservancy, compared this global warming potential of methane to new ways of measuring global warming potential called GWP star. What the authors summarized is that at a constant rate, an annual rate of methane may be misinterpreted as having 3 to 4 times higher impacts on warming than what is really observed. And if we can correct for that using GWP star, it can really dramatically impact how we measure. So the authors conclude that a sustained 0.35% annual decline is sufficient to stop further increases in global temps due to ag methane. This is analogous to the impact of net zero CO2 emissions. A 5% reduction could actually neutralize the additional warming caused by ag methane since the 80s. Okay, so actually we could even see, as we reduce methane, 5% isn't much, y'all. We can do that through better grazing. We can do that through ionophores and other approaches. The other thing I do want to say, though, is that if we see methane rise faster, the heat will be turned up quicker as well. So you can't have your cake and eat it too. But the point is that we tend to measure methane wrongly. And then it actually emphasizes a higher greenhouse gas footprint in agriculture than what potentially is happening. The other thing that's important is that if we get rid of meat and we go to a very high plant-based diet, it's going to require greater tillage, greater pesticides, and considerably more nitrogen fertilizer and not less. And so there are a lot of unintended consequences likewise that we can see from doing that. The other thing back on carbon now is that when we went in to our farm, we went in 2012 at those sites I showed on GPS, and we went in and took, I don't remember how many samples, and basically came out with about 35, 37 and a half some odd tons of carbon on our place when we started to really try to manage differently. So I want you to keep that in mind. We kept measuring, we kept doing research. And here's a paper that I'd like to talk about that was done by a former student, Paige Stanley. I'm very proud of her. She's finishing her PhD at Berkeley and is now going to Colorado State to work with Francesca Catrufo, that is, to me, one of the world's best soil carbon scientists that we have out there. And so what Paige did is she actually took real data from our grass-fed approach and compared it to real data from a feedlot approach from the same genetics off our farm. Over the years, we've had some cattle that went in on a grass-fed model. Some went into grain-fed. We captured performance. We had real data, and we pushed forward on that. And so what we effectively did then is that we looked at the LCA, the life cycle assessment. Again, a CO2 equivalent per kilogram of beef produced. A couple important caveats. This was from weaning on, comparing two finishing systems. I didn't have the cow in that model, okay? And it's important that be brought up, right? And so one thing that I also want to say is that when we compared the grazing that we did, the adaptive management, if you want to call it, grouping cattle up tighter, keeping densities higher, grazing to recovery, longer periods of recovery, really kind of looking at like how bison or other natural ruminants migrate the prairies globally, effectively saw that our approach to grass finishing had 40% greater production than the traditional literature on continuous set stock grazing. And I consider that to be super important because when we compare grain and grass, you know, we tend to see these really dwarf numbers. And so what it does show is that we can use adaptive grazing as a really big benefit. And by doing so, it dramatically lowers the footprint of that product. We hypothesize there's greater digestibility of our forages. The animals are gaining faster, and they're also having less enteric methane. So when we went back in 16, we saw a significant increase in carbon. We know that carbon can increase in soils based on dramatic changes in management. And I think that this is probably part of what we saw. And so we went in and we actually sampled and saw a considerably higher number in about a 4 to 5 year window. We actually put that soil carbon number into our grass finishing footprint. And so what you'll find is that in a normal feedlot setting, it's normally 30 to 40% more efficient than a grass finishing system. There's considerably more fossil fuel, there's higher energy, there's all these things that are coming into that system, right? So that's not rocket science, we know that. And it isn't good or bad, it is. And what we also found though is if we apply the amount of carbon we saw that dropped, the sequestration numbers, we actually saw from post-weaning on a net sink of carbon in that system, okay? A couple more things to talk about though. Number one, we did a land comparison. And in that model, it's going to take about twice the land as it does a feedlot system, right? That even in our very best grass finishing, we're not putting 200 units of nitrogen on 220 bushel corn. And it's just a very different system, and it's a much less energetically intensive system. It's more reliant on photosynthesis perhaps than fossil fuels, but it takes more land to get the same amount of beef. And if it takes more land to get the same amount of beef, we also have to acknowledge that carcasses in a grass finishing system are typically considerably lighter. Therefore, it's going to take more cows to do the same thing. Okay, so those are some things to think about in this system. All right. Where is the big industry impact here? I think that we manage our cows adaptively as much as possible. We perhaps get more grass into our feedlot systems, but we simultaneously use the right technologies in the feedlot to efficiently finish beef. I'm not one to put a grass or a grain-fed model against each other. I think they both have their place, and so that's just kind of the way I roll. In our own context, we've dramatically reduced the amount of fertilizers and things that we need. But it could be in certain other contexts, there might be a necessity to fertilize to get green things growing, to improve productivity. So I really, again, think about this in principles. Minimizing disruption does not mean no disruption at all, but I think we're just being more selective in how we do things. The last project I want to talk about before I close and kind of go through some things that we're finishing up and working on is the aspect of some work we did at White Oak Pastures, which is the largest like whole food supplier, organic whole food supplier in the Southeast. This farm has about 2,500 acres. That's it in 2017. We went to the same site in 1993, which was the oldest we could go back on Google Earth. As you can see, we didn't have color back then on Google Earth, but you can see that there's significantly more row crops in that system when you go back. Goodness, oh shit, what, 30 plus years, okay, or close to it. And so what this farmer does is he takes this degraded cropland, cotton, corn, peanuts, others, and the first thing he does is he begins to put considerable amounts of hay on these degraded systems. And then he begins to graze, put cows on there, and kind of mob grazes a bunch of hay to try to get more life back in the soil. The next thing he'll do is he has his own packing facilities. He'll actually put compost across those degraded systems. He'll plant Bahia and Bermuda grass, some very simple warm season improved grasses typically. And then he'll begin to get more grazings into the system. He'll graze poultry. He'll do other things. He'll begin to no-till cool season annuals into that system for grazing this time of year down there, and does some really cool stuff. So what we did working with General Mills and Faunus is we went in and did a complete life cycle assessment of all the things that he's producing, combined with some land equations. And we also did a chrono sequence of soil carbon across those sites. So effectively, basically, we can't go back to 1993. So there were sites at this farm that had been just new to the transition, 5 years to the transition, 10 years to the transition, 15 plus. Importantly, the one at 15 plus had never had any compost or any type of poultry impact. It was strictly grazing because it was a site considerably further away from the farm. It was way to the east of even this picture, right? So I want you to keep that in mind. So what did we find when we went back and we looked at the data? The data up front, obviously the landscape highly degraded, 10 metric tons. Remember where we started, we were kind of in this mid 30s to high 30s, somewhere in there, right? And what we found is that through this chrono sequence, improvement in soil carbon figures over time, such that the 15-year was actually in the low 60s. The 20-year that had not had poultry impact or compost was a bit smaller, bit lower, I should say. We went ahead and reported the data as linear. You could probably have it reported as quadratic if you wanted to. The point, though, is that this 15-year was kind of a bit of it was very close to their packing facilities. They had a lot of poultry, and that poultry provides considerably greater nitrogen flow through that system. And we know that it takes nitrogen to build carbon in soil. And so normally it's like a 10-to-1 carbon to nitrogen ratio. Importantly, and I think what supports our data would be simultaneously the soil health numbers that we saw using Cornell. Water stable aggregate, dramatically improved over this chrono sequence from 0 to 50. Microbial respiration, the same. Active carbon, the same. Soil protein, the same. Interestingly, while we saw these big changes in water stable aggregate, we didn't see changes in water holding capacity. I would have to say that the reason, part of it is I don't know about the methodology. One thing I think that frustrates me in some of this is that we pound and pulverize soil to a fine dust, and then we do some of these tests. And often then we try to retroactively compare that to what's actually happening in vivo. And so I'm not sure why we saw those things that we did, but we obviously didn't see that big improvement in water holding capacity. But you can see that definitely going into that system, we saw huge impacts. The other thing is again, we can't have our cake necessarily and need it too. Net emissions on the left. In any context, the blue representing commodity in Georgia, the green representing what we call a multi-species pasture rotation, almost twice the emissions in those systems, okay? And again, is it good or bad? It just is. It's a different model. If you take the soil carbon savings that we saw again, and if you took the beef, the pork, and the poultry, all the protein produced, not just the beef, all the protein, the footprint dramatically reduces again, down to like 3 compared to 10. So a significant drop, okay? You look at, again, the land use required on a hectares needed. I did this for feed, poultry, pork, beef, all the way the total, you're gonna look at a considerably greater land footprint again. A couple of things I'd like to say is that I never have met a farmer that's really regeneratively minded or ecologically minded, whatever term you want to use, whose goal was to maximize productivity. Okay. And so could there be improvements? Absolutely. The other thing is that, like, what happens then is that we have these groups that come up with these sharing and sparing types of scenarios where, oh, well, because we're farming regeneratively at this site in Georgia, it now means that another 2,000 acres of the Amazon rainforest were cut over to for cattle, right? So these really broad-based comparisons that I'm not sure aren't very causal, but those are the things that happen as well. This is a friend of mine that's online, and the thing that I want to say here real quick is that I don't know this guy. He talks not a lot about me, but sometimes online, and he basically does not believe in our research and thinks that we're kind of bought and paid for, et cetera. And the thing though is that he spent some time doing a video on our work. I want to say that we went through like 6 to 8 months of guttural peer review to get this paper published. This person debunked our work. I don't believe he's an animal scientist. He runs something called Plant-Based News and puts a video on YouTube up. And within the first week of our paper going live, when I looked at this, we had like 1,000 hits. He had over 11,000 views on his video. Yet we were the one that went through guttural peer review. And that's just something to me that is really problematic in today's society. So kind of wrapping up the next few minutes, carbon markets are out there and we keep talking about them. I want to be sure that you guys understand carbon is variable, it's expensive to measure, and the modeling we use in grassland systems are insufficient to reflect the complexity of how carbon changes in a grazing landscape. I go back to the natural laws of capital. The transaction must yield the desired effect. If I am paying you, Jen, $100, if I'm paying you $15 to sequester a ton of carbon, you have to do it, okay? So that means we have to have accurate metrics. We have to have verification. We have to have reporting. We have to consider aspects of the permanence of the carbon you sequestered. The additionality, which means that Jen is selling carbon to me, but she's also got a little side gig and she's selling it to Show Oil as well, okay? All these things that are out there that are challenges to seeing this carbon market expand. Felt need among buyer and seller. Jen and I have to have this felt need that we both believe it's a good thing to put that carbon below ground. Today's agriculture is looking at $1,200 fertilizer costs. I don't think they're worried about CO2 emissions very much right now. And then the third thing is that the premium has to be greatly surpassed by the premium must greatly surpass the opportunity cost. What that means effectively is that when we pay a farmer $15 to put it down, but we pay an oil company $400, now today it's like $600 to extract a ton of carbon in the form of fossil fuel, there's a tremendous difference in the supply and demand incentivization of where carbon is going. I would argue today, ladies and gentlemen, that we can't check a box on either of these, in any of these. And so we need continued work and research to get moving forward. The thing I would like to say is we went in and did some spot sampling in 2020. We continue to believe that our carbon numbers are improving. The thing I would also like to say is I've learned a lot more about carbon in the last 12 years, 10 years of what I'm doing. And what I'd like to say is that the longer we do this, the less I truly think we know. I think we can run into aspects of type 1 and type 2 error. Type 1 error would be that it's effectively I'm fishing and I hear something in the woods rustling, and I look into the woods. I thought it was a grizzly bear, but it wasn't. So I thought something was there, but it's not. Type 2 error is when I'm fishing and I hear something rustling in the woods and I think, oh, it's a bird or, the wind. And I turn around and it's a grizzly bear and he's running right at me. So I didn't think something was there, but it was actually happening. And that can be the same with this work that we're doing. There's so much tremendous variation. We could have missampled in 2012. Okay. We could have had bad numbers. We couldn't have accounted for sand in a better way. And so what I want to say is that I'm just trying to be humble and say the longer I do this, the more challenging it gets. While we do believe there's some things happening, I think simultaneously we have to say there's still we need more clarification. And so that's the last thing I'm going to talk about. I think I'm getting close to my time. I'm sorry if I'm going over a few. Is a new project that we recently got funded by the Foundation for Future Ag and Research, where we're effectively not only looking at soil carbon, but we're also looking at a bunch of different gas fluxes and other metrics that are more apt to hopefully tell us how carbon is cycling through our grazing systems. We're going to see a $19 million investment. It's MSU, Noble Research Institute, and Colorado State are going to be the three leads. And again, it's funded by the Foundation for the Future of Ag and Noble primarily. We've got multiple partners that I all want to acknowledge. I don't have time to say all their names. But our overarching goal is to come in and have very intensive metrics on grazing sites to be able to understand really how CO2 is fluxing, how carbon is changing over time through different fractions in organic matter, how water is cycling, and then linking all that up to remote sensing space. We simultaneously want to also make investments in social and economic as well. And so while this stuff is all great scientifically and we're using all the best new technologies, we still need to understand the drivers of ecological function and all that stuff, but we also really need to hyper focus on social and economic drivers. And unless we understand those things, we really aren't going to see the desired shifts in our landscapes. And we need to spend more time researching those things as well. And so with that said, we're going to close on this. I believe that we can use grazing animals to improve ecology and landscape function. I think we are seeing improvements in carbon over time. How that's monetized, if at all, I have no idea. I'm pretty bearish today. I do think, though, that we can continue to see these regenerative principles adopted to add resilience into our landscapes. And what we want to do here at Michigan State, working with other partners, is we really want to see every acre, as many as possible in our state, adopted regenerative management. We want to see if that impacts the nutrient density of food. We want to see if the way we farm can improve the health of farmers economically, as well as with their social well-being, and how that overall affects economic prosperities in rural and urban centers as well. And so I believe I'm done with that. I'll go ahead and stop. Thank you all.
Thank you so much, Jason. I just wanted to just comment on one thing. I really appreciate the larger project and trying to look at things at a little bit broader ecosystem. By ecosystem, I mean all of those things, the economic ecosystem and all of that, because I feel like your point about the premium needs to greatly surpass the opportunity cost. I don't think that gets talked about nearly enough in the farming. Farmers know it, farmers own it, that opportunity cost is everything. And that doesn't always make it up into policy and larger scale folks. So we have a few questions, and technically we're supposed to end right now, but that's not fair because there are some great questions out here. No, this is wonderful. We also built in a little bit longer time for our lunch break time. So I'm going to ask a few questions. Cool. So thank you. So one of the questions was around feeding seaweed to reduce enteric emissions, and the question was, do you think that that's something that has potential and is scalable? Is that something that you guys have tried at your place?
Great question. And there's more data out there to suggest it's happening, right? That by feeding, I believe it's red seaweed, that we're seeing dramatic reductions in enteric methane. Ermias Caria at UC Davis has really been a leader in that research, and the data seems pretty exciting. And so I've never been like I've never done that kind of research, right? Where we look at feeding byproducts or other types of things. That's just not what we've done in the past. I think there's immense opportunity. There's a ton of VC going into it right now. I mean, there's just like, you talk to a lot of venture capital and they're trying to scale it up. And that's the big barrier, is that when you look at what it would take to grow all of this and to get it into a cost-effective way into a ruminant diet, that might be a bit more challenging. But I think obviously that's something you can't ignore when you see these 70% reductions in refereed papers on that. And so I'm all for it. I'm not like a purist, y'all. I believe in ionophores, and I know people consider them to be an antibiotic because of their shape. We can get weight gain, and we get methane reduction, and we get greater productivity. I mean, to me, that kind of offsets the shape of the molecule. And so, but I do think there are opportunities for seaweed and other types of potential additives that can help in doing this.
Well, thank you. There is also a question, actually, I guess on that sort of subject of other ways to amend or add, whether through the animals or on the land application. We've also had a question around on a small farm that is a mixed hardwood, hay, open land, pasture situation. Even if the amounts are small, is it a logical thing to be taking charcoal from the hardwoods and using those to amend the soil? Is that
Yeah,
a worthwhile holistic approach?
Yeah, biochar, right? And again, I talk to the I get calls from folks that really want to scale biochar up. And they've always had these challenges with getting it to market, with trucking, with, these big absolutes. But you know what? Every site, no matter where we live, there's always some unique advantages to where we are. And there's some unique opportunities to obtain, whether it be, fertilizers or cheap byproducts or other things that can provide an advantage. And based on the work of using biochar and kind of the ability for it to create some scaffolding for carbon and some improvements in microbial activity, by all means, if you've got it, use it. I don't see any problem with that whatsoever. Generally, I'm not a rock star on the numbers, but you go down to drawdown, and the original drawdown I prefer a lot better than the second one. But there are documented significant potential improvements in soil carbon uptake with the use of it. I don't know again how you use it at scale or create these bigger markets, but at a small localized level, I think it makes sense.
So could you also take a sec to speak to concerns about soil carbon saturation?
Sure.
Yeah.
So when we look at saturation, it's often pushed back to say, oh, well, it's all great and well that you might be able to build carbon. But simultaneously, even if you can do it, it's not going to last that long. It's going to saturate. You've got a soaked up sponge, and we're still SOL. And so what I'd like to say is that philosophy should change. And that's based on the very best science that I'm aware of in this space, has been done by Dr. Catrufo and others, but her primarily as a leader on looking at the different forms of organic matter in the soil. And what we're learning is that, you look at the different fractions. We have a larger pore size or a larger sized fraction called particulate organic matter, and a smaller mineral associated organic matter. Well, the latter, the mineral associated organic matter, is actually the carbon that is microbially processed and bound to inorganic material. So it's associated to mineral, and it's highly protected, highly protected. You look at particular organic matter, it's that larger duff, right? It's like that kind of mulch layer that you start to see when all that stuff that you lay over begins to be taken up into creation of soil. And that is more labile, considerably more labile. What I would like to say, though, is that based on work published in Nature and other ways, we do know that mineral associated organic matter saturates. There's only so much surface area for a mineral to bind carbon. What I will also say is that based on the work that Francesca's done, is it's almost like double-digit soil organic matter. So only until you start to see some really crazy great numbers are you going to see that completely saturated. It's obviously going to vary by geography. We also know that the more labile particulate organic matter, it never saturates. It continues to climb linearly. We see more mineral associated in grasslands. We see more particulate organic matter, duff, in forests. So I think that often those that push back on these things and talk about saturation really fast are using it more as a red herring than really as a scientifically founded or based actuality. And so look, if we do saturate it across the world, hell yeah, high five, job done.
I love that. Thank you. Yes, job well done. Let's do it. I don't want to hold you forever, but I did.
No, I'm good.
Yeah, I was gonna say I did want to try to wrap up with a general question of folks who are interested in this topic, who are clearly the folks on this meeting today. Where are some of the places that we can go to get more of this information that you're sharing? Because we don't always see it, and we definitely, need to see it. And are there ways that we can support your work? Stefan is our closing speaker today, so I'm very excited that you've set the stage for him. Thank you.
Right. Yeah.
But how can we support the work that all of you are doing and learn more about this ourselves?
Yeah. So look, I think, I'll be honest, like I think what we're seeing, like what we've seen, we could be a tremendous outlier, right? Like, I don't know. We're going to really intensely measure again this year to kind of get a better gauge over time. We changed our systems dramatically with our new project, working with CSU and the Soil Carbon Solutions Center. We're going to be like really putting a lot of this to the test. But what I would like to say is that, to me, the main principles that drive improved resilience in our farmscapes should be of absolute importance. And that is focused on adding resilience, being profitable, improving biodiversity, water cycling, etc. We can go to the literature and we can go to some of the best models that are there, and they can help, right? I mean, whether it be Comet, I see Dr. Rotz, whether it's the model that they've been working on at ARS and others, right? That I think are getting better and better to help predict this stuff. The fear I've always had is that the answer is always 0.1 to 0.3, no matter if you're wherever you are, because the oversimplification of how we do this stuff. And so I think, where do you go to find out more? I think from a standpoint of improving landscapes, I mean, there's tons of, whether it be through, what y'all have done in Vermont, that with the grazing land coalitions and all these entities that are out there, the understanding ags of the world that I've been thankful to work with over the years, the extension folks and ARS folks that are out there doing this work. I put a lot of value in what they're doing, and so the internet's pretty powerful, but there's also a lot of bullshit too. So you just got to be really mindful, right, of kind of where where all that goes and what you're really thinking about doing it. But if you're just chasing carbon, I probably don't find that to be a very fruitful endeavor. But I think this broader picture of well-being is really important.
Well said. And thank you again so very much for joining
You
us
bet.
today, giving
Dude, I'm
us
gonna
lots
hang
to
out,
chew
listen to
on.
Spawn. So
Yeah, do it.
great.
We would
Okay.
love to have you on.
Thank
So-
you all very much. If anybody has any questions, feel free to email.
Thank you so much, Jason. And okay, folks, so we will close down this link and we will start the next session with George Lake at 12:15. So we'll look forward to you then. Thank you.
Hey, Jen, send me the new link.
I will.
Thanks.